everyone, we're Group 36, and this is our EME 303 project. Have you ever been at a bar and somebody comes up to you and hits the top of your beer bottle with theirs, and you're left with a big foamy mess? The question that we wanted to observe was why exactly this happens in the terms of fluid dynamics. A basic rundown of this process is that when one bottle hits the top of the other, a pressure wave is sent through the beer, and it hits off the bottom of the bottle and travels back up. The pressure in the beer increases when this happens. And when this happens, the bubbles quickly form and erupt to the top of the bottle. The bubbles are gradually increasing with CO2, which causes a foam over.
Depends on the ideal gas law, PV equals to nRT, and the number of moles of the CO2 that doesn't change, and the temperature doesn't change as well. So when the pressure increases, the volume of the bubbles of CO2 decrease, and it will generate many new small bubbles.
As the breakdown happens in the bottom of the bottle, thousands of smaller bubbles absorb carbon dioxide as it moves along through the bottle. And as the volume decreases initially, the weight of each bubble will decrease as well. Then, as the buoyancy force applied on it, it will drag all those thousands of little bubbles upward. And during that process, thousands of little bubbles would be able to absorb much more carbon dioxide than the previous single large bubble. And as all those little bubbles become large enough and reach to the surface of the liquid, which is the beer, it will then rapidly become the foam and boomed out of the top of the bottle.
One good question is, why does this not happen when you cheers? So basically, if we strike the bottle sideways, then the bottle and the liquid all move as one, plus a bit of splashing, no cavitation, and any small bubbles will be at the top of the beer. When two bottles are hit on their side, no pressure wave is sent down through the bottle, therefore there is no increase in pressure and no bursting bubbles. In conclusion, waves bounce back and forth several more times until they are damped out. The presence of a relatively close-free surface is the key to form the chain of expression compression waves that drive the bubble implosions. Our buoyancy sources come from the rapidly growing bubble clusters. This leads to the formation of bubble whose void fraction increases quickly, turning most of the liquid into foam.
Now we learned another trick, and you can do that to your friend next time in the party. Are you ready to do that? Thanks for watching.